So, welcome to our channel Electronics on Wheel, and don't forget to like, subscribe, and comment on this channel. This is what we ask as a fee for learning new things on this channel. So, we are running, as you know, one series where we are discussing from the basics of the wiring diagram, where we are discussing about the ground, where we are discussing about the fuse, how to read the wiring diagram. So, in that series, this is the seventh video where we are discussing about the fuse box. So, we have taken one example of Mahindra Bolero. Uh, so, where we are going to discuss about all the components and the systems which we are using in this vehicle. So in ground we have last time we have used discussed about the ground. Now let me start with the fuse box. So in fuse box and relay location, so these are the main fuse box which we are using here. So let me go one by one. So first is the main fuse box which is placed here on the driver side. As you can see, this is the main fuse box. We will discuss about what are the fuse box, what are the functions are governed by these fuse box, what are the fuse ratings, we will see in the next slide. Then we have the second fuse box that is coming under this. So this is under the co-passenger side and co-driver, you can say co-driver and not co-passenger, that is passenger side or the co-driver side. That is our ECU fuse box. And ECU fuse box, because our ECU will be somewhere here, that's why we have taken this ECU fuse box near to that ECU. Then we have the third one, that is the maxi fuse. So maxi fuse is nothing but, as I told you, this is the primary fuse. Earlier also I have told you there are two types of fuse box. One is the primary fuse box and second is the secondary fuse box or main fuse box or ECU fuse box, whatever you want to say. So in primary fuse box, generally we govern with the mega fuses or midi fuses, where you have the big fuses from the battery. So if you see the location of this third fuse box which is coming, this battery will be placed somewhere here in this vehicle, and it is near to that particular battery, that this primary fuse box. So these are the three fuse box. We will see what are the fuses inside these fuse box in the coming slides. Then fourth one is the ECU main relay. Then fifth one is the feed pump relay. And fourth location, if you see, the ECU main relay is also near to this, because as you know the ECU is placed somewhere here. So that's why ECU fuse box, ECU relay, and all these three things are all together are placed or packaged in the vehicle. Then feed pump relay is on the fifth position, so you can see here that is also near to this. Then we have the GNS relay. GNS relay is nothing but the which is placed here, and it is used in the starting system. We will see that when we will discuss about the starting system. Then seventh is the starter relay. This is here. And then we have the EMS ECU. EMS ECU is nothing but the engine management system or engine control ECU, you can say. So where your engine, all the engine control functions are governed by this ECU, where it is your fuel injector, common rail relay, all the things are governed by this. So this is how uh, the EMS ECU is placed. Then you have the immobilizer controller, that is on the ninth position. You can see this is on the driver side, near to your instrumentation or the cluster. So this is the overall breakup of the fuse box and relay location. Let me go inside the fuse box. So first is the main fuse box. In main fuse box we are using total 14 fuses. So these fuses are used for the functions, as you know. So these are the functions name. Then you have the rating, what are the rating for that particular fuse we have used for particular function. Then what is the color of that particular fuse, and what is the make, what is the supplier for that particular fuse. So this is the first function, that is the accessory relay. So this is the function, the first function, that is the accessory function, where we are using the 10 amps of fuse, and it is in the color of red, and Pacific is the make or supplier. So all these uh, fuses are made by the Pacific. You can have the little fuse also, but right now we are talking about this Pacific supplier. Okay. So the second function is roof and engine compartment lamp, then which is 15 amps. Wiper washer, that we have 15 amps. Then park lamp, which is 10 amps. stereo, which is 7.5, cigar lighter, that is 15 amps, fog lamp 15 amps, turn and signal, that is 15 amp. So see, if you are seeing the turn signal and reserve lamp, so for both the functions, turn signal and reserve lamp, they have combined this particular fuse in a 15 amps. So this is how they have combine the fuses. As always, you have to be very careful which particular function you can combine together. So if you see the 10th, so here horn and stop lamp is combined, and they have given the 15 amps of fuse for this particular function. But if you see the ECU fuse, so you cannot combine this particular ECU fuse to some other function, because it is very critical. If your ECU itself gone, then your whole vehicle is gone, because ECU is like a brain for the particular vehicle. Because if ECU is not working, then nothing is going to be start and your vehicle will be dead. Then you have the hazard lamp, that is the 15 amps. Then headlamp high beam, headlamp low beam. So always, I have always told you that you can find out your load value from the fuse also. Okay, if you are seeing here 15 amps, exact value you cannot find out from the fuse value, but the approximate range you can find out. So as we know already, we have discussed many times this, that the what can be the load for this. So 60 watt or 55 watt for the low beam. So these are the few, these are the headlamp load for the fuse, for the headlamp, sorry, these are the load value for the headlamp, high beam and low beam. So if I take the example of 60 watts, so as I told you that very simple, that 60 and we are working on 12 volt, then you have the 5 amps. Okay, but as I told you this thing, that this is a one side, so you have to take the total 120, and then if you will calculate, so it will come around, the current value will come around 10 amps. And if you take the 1.35 or 1.25 of this value, then it will come around 13.5, right? 13.5, then what would be the next fuse value? That would be 15 amps. So this is how you can calculate. So here I told you little fast this calculation. You can watch my previous video where we have discussed very in detailed way that how to calculate the fuse value of for any load. And these are the spare fuses. If you see that these three fuses we have kept, so in every fuse box you will see some of the fuse values or fuse slots will be available, or spare value or free. Because sometimes suppose one particular slot is not working or completely dead, so we should not change whole fuse box, so we can take the particular connection from this spare fuse. So that is also one reason to keep the always some of the slots as a spare or the free or available for the use. Then we will see the ECU fuse box. So in ECU fuse box, these are the function name, rating, color and make. So as I told you earlier also, so this is the fuse box which is placed here on the second. Then EGR actuator, we have ECU supply, then fuel pump relay. So fuel pump relay also, the you need the fuse for that particular fuel pump relay. You have to protect. Okay. Then cluster, you have the 10 amps brake switch, 15 amps mode selection, then 10 amps. Then you have again two fuses, that is spare 10 amps and 15 amps. So as earlier also I told you that why we keep the spare fuses, because there is a possibility that some of the slots goes wrong, or got damaged. Then you can use the particular slot for that particular function. Suppose brake switch slot got damaged, then you can use this particular 8 number of spare fuse. So this is also one way. And sometimes to keep the spare fuse also, this is the strategy. Then third is the maxi fuse. So maxi fuse, as already told you, that this is nothing but the primary fuse box, and primary fuse box plays a very critical role. And always these are the fuses which are like mega fuses or midi fuses, where you can see the starter relay fuse and ECU main relay fuse. So 60 amps of fuse we have used for the starter relay, and ECU main relay fuse we have used the 30 amps of uh, fuse value, such 30 amps of fuse we have used for the ECU main relay. So these are the fuses which we have used. So this is the overall detail of the fuse box. What are the functions and what are the fuse value we are using for the particular function. Then we have the wiring harness topology. So this is the full vehicle you can see here. So what type of harness we are using and what are the harnesses we have to take. So we have to create one topology where we can divide our harnesses. So this you cannot say these are the like 12 harness. This you can say that wherever we have to take the connection, that is the topology of this wiring harness. So you see, first is the instrument panel. So this is the instrument panel area where you have to keep, one second, let me change the color of this so that it will be more clear. So this is first is the instrument panel. Then you have second is the engine. So this is the your engine where you will be having the fuel injector, EGR and other stuff, right? Sensors, other sensors for the engine functions. Then you have the chassis. This is the third one, that is for the chassis. You have to take the this connection. Then fourth one is the roof lamp you will be having. So as I told you, this is a Bolero pickup truck. Okay, so you will be having at least the roof lamp here for the driver side. Then you have the lock set illumination, that is the fifth one here. Then tail lamp in the last, you can see here. This is the this connection also you have to make. Then float unit, you as you know, this is nothing but the fuel. Then we have the eighth, which is the cluster pigtail. So cluster pigtail is nothing but here, where you are in the driver side and you have to take the sorry, you have to take the cluster on this side, your driver here, so cluster. Then headlamp, you know already that this is your left and right hand side. Sorry, if it is this side the driver, then this would be your right hand side and it would be the your LH. So this is the headlamp. Then combination switch, as you know that combination switch is nothing but it will come here. Then handbrake, I will show you some of the combination switch. These are all the components I will show in one of the video where you can understand more better what is the combination switch. Combination switch, as you know, if you are working in automotive or if you are familiar with the vehicle, you know that combination switch is nothing but which you control all the functions of lighting and other stuff, and it comes on a steering. Then you have 12th is the ECU. This is your ECU which is placed, as already we have discussed. You might have seen the earlier the location of the ECU relay, fuse box, and these are the position of the ECU. So because the ECU is placed here in this location, so we have kept everything. ECU fuse box also we have kept here, and ECU relay also we have kept here. In one of the video, I will tell you why we keep the one particular ECU fuse box near to the ECU position. Okay, so there is a logical reason behind this. It is not like that we have just kept the ECU and ECU fuse box near to each other. There is a specification of the ECU also, where you cannot keep your power source distance wire length in a particular range only. So we will discuss this point also, but in other video, but not in this video. But as of now, you understand the packaging location of this ECU fuse box and ECU main relay. Power distribution. So earlier also I have told you there are three types of generation where you have the power distribution. So first is the centralized power distribution. So as of now, whatever you have seen, that is the centralized power distribution, where the solution with fuse and electromagnetic relays for the primary and the secondary power distribution. You did not see anything which is integrated in the electric PCB format. Okay, everything was as a manual fuse box, where you can you have to replace or spare fuse, which you might have seen. So some PD function moved already to ECU, we will see. So if you see the PD function, it is nothing with power distribution function. So as one issue we are using, and there might be some function which are already governed by the ECU itself, as to show you that ECU main relay, right? And ECU fuses. So this is the generation first, which I have given you the example currently. The generation second, in what happen in generation second, so partially or up to fully electrification of primary and secondary power distribution. So some of the function will be integrated in the primary fuse box and secondary fuse box in terms of PCB. And so what will happen, increasing the flexibility of decentralization and wire harness reduction. So if you see here, the fuse box will be distributed on different location. But if you see in the last example, we were having the fuse box in the this region only, right? We were not having the fuse boxes in here. So you see here, so most of the companies are using this right now. And third one is the generation 3, that is decentralized power distribution, where you have the four different zone controller. So this is the concept of zone controller in electrical and electronic architecture. One video we have created where we have discussed about this zone controller, where by doing this we are reducing the wiring harness and reduction in the cost, reduction in the weight of the wiring harness. So former secondary power distribution is transferred into primary power distribution and mainly into the zone controller. So whatever we were using as a secondary power distribution, so everything is converted into the zone controller unit. And you won't believe that all the secondary fuses are integrated in these zone controller, and you will not be having in the physical fuses, I would say. They all are integrated in the PCB format, you can understand. So you have no need to take out the fuse and all those things. They are converted in the form of MOSFET fat in the PCB format. We will discuss this thing someday in detail, how their zone controller, they have integrated all the fuse boxes in fuses in the PCB format. So zone controller becomes the secondary power distribution, and it is fully electrified. Okay, so this is how the power distribution happen. And so today we have understand the what is the power distribution and how the fuse box is governing. So in next video we will take one of the example of any circuit, and we will try to understand the some of the circuits like charging circuit or starting system, that how they are controlling and how they are behaving in the vehicle and what are their functions. So thank you for your time. If you like the content of this video, please like, subscribe and comment.